matplotlib overview lecture. Now, in this video, we'll be looking at two visualization package. One is matplotlib, and the other is seaborn. So, matplotlib is a visualization package within Python, and it came like a simulation of the MATLAB. In case you are familiar with MATLAB, you will find it useful. Now, one thing we have to be very careful here that matplotlib and seaborn are used extensively when you are doing data science kind of work. Since our workshop is on machine learning, we'll just focus on the basic aspects of matplotlib and seaborn. We'll not go into very deep into it because data visualization, which means that you take a group of data and visualize it as a graph or a plot, is itself a skill in itself. Okay, so it's an ocean, and I don't want all of you to get go deeper into it because our focus is machine learning. Okay, now so let's get started. To install it, you can just go to your terminal and type conda installed matplotlib. If it doesn't work, you can also do a pip installed matplotlib, but I think it will work. Okay, now let me just clear the outputs. Okay, so bear with me a minute. Yes, and let me go step by step. So first step is, we import matplotlib.pyplot, which is the sub package as PLT. This is standard. You can give it any name, but stick with PLT because every reference you will have on the API list. When you go here, you can go and see some, examples and tutorials. Most of the stuff I'll be showing is from the official website of matplotlib, and all of them, use as PLT, as you can see it. Okay, so if you really like what I'm showing on the matplotlib, you can just go and see some additional examples from this site as well. Just come to the matplotlib homepage and click tutorials. The URL is given in the login page. Okay, so after we have imported it as PLT, we make it inline. What does it mean? It is only used for Jupyter Notebook. In case you are using a different ID, you need not give it. But it is used for taking the graph which is generated by Matplotlib inside the Jupyter Notebook. Okay, in case you are not using Jupyter Notebook, you have to put plt.show. Okay, let's do an example, and then I think it will be clear. Okay, just me clear all the outputs. Yeah. So first let's create our data set. It's simple. I'll not be typing, so I do a linear space, and just multiply a variable y, which is x into 2. I'll be basically plotting them. So if you can see, x is an array from 0 to 5. From 0 to 5, if you've done numpy, you know what linspace does, and y is basically a double of that, which is point 1.5, 2.25, 2 is 4, 2.5 is 6.25. Nothing to explain. Now let's try to plot it, this x and y. So you can also use the shift tab, which means if you want to see any function, and you can just type and you press shift and tab, it will give you the arguments. Okay, so if you want to know about any function, you press shift and tab and it will tell you the API. So plt.plot takes in two arguments, and it is used for plotting of y versus x. So what are these two arguments? One would be your x variable, the other is y variable, and other is the color which you want to give. Okay, so let's see that. So this is x, this is y, and this is the red color which plot is happening. I've also additionally put the label, which means x-axis title here, and I can easily go and say age versus height, maybe, if I want to make some um, make some sense out of the data. Just for an example, um, and we call it our first graph. See, so it makes more sense. We have the age versus the height, and yes, that's how it works. Now this is how you do it directly. I'll be also showing you how do you do it with function calls. Okay, but that part is coming later. Now, we also have multi-plots, which are stuff like this. You know, if you have to do two plots in one go. Now, this concept is quite interesting. How we do is that we create subplot. So, if you just do a shift tab, I think you can see the signature again. It takes the arguments and the position of a particular grid. Now, what does it mean? 1, 2, 1, 1, 2, 2. So for this particular thing, this number 1, it means the subplot 1, and this number 2 means the subplot 2. And this is the percentage of the canvas space, which means if you imagine this whole white space as 100, how much it is taking? If you just do a reciprocal of it, it actually means this, the first two argument, which means for this particular subplot, when it comes to the length of it, you take the entire length, and when you have to take the breadth, you take half of it. Okay, now if you just change it, it will get reversed, which means um, and if you try to just change it, you see it goes on the different side, which means number of rows by number of columns by plot number. Okay, so number of rows, which is two rows, I am saying one row, two row. So I have two rows within the entire canvas, which you are saying, and then one column. See, it's one column. Okay, so that's how the plotting goes. And R is like, you know, it's the style which you give. You can see it in the API list in the website, just like you know, MATLAB, you give R and G for red and green. Okay, now this was the direct way to call matplotlib. There is also an object oriented way in which you just call the methods or attributes of an object on which you have created the figure. So let's see how it goes. Okay, now if I let me just insert a cell above and try to show you. If I just call a object which is like fig in this case, which is for a plot, you will just get a method out of it. As you can see here, it is showing that particular method. Okay, it's something like an empty canvas. Okay, now we will use an object oriented method to call it, and here similarly, we just create an empty canvas and assign it to a variable which is fig, and then call the attribute of that particular thing, which is add axis, which is particularly which you see here, and then again it gives the percentage, like, you know, 10% on left, 10% on bottom, 80% on width, and 80% on height. And bear in mind the range has to be always between 0 to 1. Okay, and again you set the labels and the title. Okay, so it would look something like this. Okay, so here you are saying that 10% of the length, 10% of the bottom, 80% of width and height of the entire canvas. That's what you are saying. Now, if you look at the next example, this would be clear, because you might actually draw two plots into it, which means when you are saying that axis one, this is axis 2, which is one subplot within the main plot, and if you're trying to show this, um, you see that this axis 2, this is the smaller graph, is taking 20%, 0.5%, 4 and 3. So if you have to take this down, you can just increase the value and see that this particular thing will come down. See, it's going to the left, and let me just play with it. Maybe put it 7. See, you can play with the parameters here, and it goes up and down depending on how much position of the screen you have. So I think I suggest you play with this parameter to understand how the positioning works for the for the subplot inside it. Okay. Now, I think that's a decent amount of subplots that we have done. Now, there are other examples which you can see, but I'll not go through into it. These are just something to do with your contrast and DPI. You can just have a look into it. If you want to save a figure, you can also put the save fig attributes, and it will save the figure. Okay, I think that's it more or less. There are some other additional stuff given on plot types and other plot range. You can have a look into it. So that completes how we do matplot in general, both by the direct way and the instant creating an instant, which is the object oriented way. There is another thing we need to see, which is seaborn. Now, seaborn, which is here, seaborn is a library which is built on top of matplotlib to give make it more fanciful and more attractive in terms of contrast and color, and doing multiple types of charts, not only the simple linear kind which I showed. So we'll be just focusing on the distribution plot. Okay, how do you distribute? And to install it, you again go to Conda, import seaborn. It's already given in the page. You can go and have a look into it. You can also go into the tutorial section and practice on the univariate example. Univariate here means single variable. Okay, and most of the examples I've shown you, I'll be showing you is from this particular page, which you can use and practice. Now, coming back to seaborn, let me just clear the output which are already there. Okay, now you import seaborn as SNS and do matplotlib as inline, and then this SNS has a default data set which is called as tips, which some looks like a hotel. You know how many persons have come to a hotel, at what date and time they have come, how much have they ordered in terms of the food, and what is the tips they have paid. So that is the tips data set, which is given by default. You do not have to put a file. You just need an internet connection, and it is pulling up from the internet. Now this is pulled up from the internet, and this is just shows the serial number, how much was the total bill, how much was the tip given, what was the gender of the person who came to eat, was that person a smoker or a non-smoker a day, and was it a dinner and a lunch, and what is the size of the people who came in. So it's a simple data set. Now, if you have to do a distribution plot of a univariate variable, which means one variable, you want to plot one variable, which is total bill out of this particular data set. What you can do is that you can call SNS, which is the name I have given, like seaborn as SNS. I'm calling seaborn, and within seaborn, I'm calling the distribution plot API. Which, if you see the signature here, it gives you all the attributes this particular signature is taking, this particular API is taking. But we'll just use the current. We'll make it simple, and we're just calling the tips data set, and within tips we're calling the total bill, which means that go and fetch the tips database, and within that column total bill, do a distribution plot. And you can see that there is a distribution plot which has been created. I'll just zoom it a bit. Okay, so this is the distribution plot created on total bill, which is just one one variable in that particular data set. Now let's see what we can do. Now if you see carefully, there is a line which has come up, and in histogram you generally don't see a line, you just see the towers. It is coming because the signature which you see does the KDE of it, which is the kernel density. So ignore KDE for the time being. When we'll do machine learning, I'll be talking about KDE, but you can just recall the function again. You can put KDEs as false, and beans is the number of total towers you want. So you can increase the bin size, make it 40, and even if you make it 40, the interference, you see that most of the bills were in the range of 10 to $20 in this particular data set. Okay, bear in mind, if you make the bins very huge, like 100, you will not be able to decipher from the data. It would become too scattered. So I would suggest you stick to a bin size of 30, and then you can infer the data that between 12 to 20, that's where my towers are, and probably that's the average range of the bill versus the tip. Okay, now let's see what else we can do. We can also do two distribution plots for two variables, which is a bivariate data, and you can create multiple types of charts into it. Like let's start with scatter plot first. So, and if we just you can again do a shift tab and see the signature here. So if you want detail, and this is what I'm changing the kind, and the data is equal to tips. Okay, x and y variable, I just have x is equal to total bill, y is equal to tip. So take this two variable wherein x is equal to total bill, y is equal to tip, data is equal to the tip data set, and kind is a draw a scattered diagram, and I'm ignoring the rest of the parameters which are given. Okay, it will, if I ignore it, it will take it to the default, and as you can see that it is drawing the scatter diagram of total bill, which is in x, versus tip, total bill in x and tip in y. So total bill in x, tip in y. Okay, now if you want to draw a hex diagram, which means it's the same scatter diagram, but if it has more points, it will do a hexagon and change it to a deeper color. So this means that there are a lot of data sets here. So it's basically the same data plotted in a different kind to show. It also shows your peak of coefficient and stuff like that, which you have with, if you recall scatter diagrams in your statistics paper, it shows all those kind of things. You can also do general regression, which is a straight line, which perfectly fits, in a way, fits the data sets. Okay. You can also do pair plot, which means you can draw all the variables against all the variables. Previously we did only two variables. Now you can draw all the variables. So you can do total bill with size, you can do total bill with tip. So all permutations and combinations, if you want to see, you can use this particular function. Okay, so I'll just zoom it out so that you can see it. Yeah, so you can see that it has drawn all the pair plot. So that's it, guys. I think there are more things given, but you can ignore them. I think till pair plot, if you do, you are done, and you have to actually play around with the code. I would strongly arrange you to change the numbers and see how it reacts, and try this Jupyter notebook out. These two Jupyter notebooks, and if you want more, you can always go to the tutorial and practice. Okay, so I think this was helpful. Might be a little confusing when you start, so that is normal. But I think once you get a hang about it and how to call the signature in matplotlib and seaborn, it would be easier. Thank you, and I'll see you soon.